Today we're learning to divide fractions. And before we do that, let's write down one thing that we need to remember. We need to remember that we have two notations for division. We can write 2 divided by 2 like that, going horizontally, or we can write 2 divided by 2 like that, going up and down, going vertically. These both mean the same thing, and it's going to be important in just a second. So with division, we are using the axes, so we don't have to have common denominators. And what we really want to do for division is we really want to just divide across, just like we multiplied across previously. Divide across. So here, 8 divided by 2 is 4. 15 divided by 3 is 5. There's my answer. Done. It really is that simple. Or not, because right down here, 3 divided by 7, 7 isn't something that goes into 3 an even number of times. So this is why what you learned in 6th grade was that there was another way to think about it. We can either divide across or multiply by what's called the reciprocal. And remember, the reciprocal is just the flipped over fraction. So that means that whenever we have something, some fraction, divided by some other fraction, that's the same as multiplying that first fraction by the flipped over second fraction. You see here c over d divided by c over d, same as multiplied by d over c. So what you saw in 6th grade is you saw this, 8/15 times 3 over 2. And this works great. It's really simple. And it's one of the things that people forget in high school all the time, because this is the only time that we ever are allowed to just randomly flip over fractions. And so then people start trying to flip over other stuff, and it's just like, wait, what is this all going on? So I'm just going to explain to you where this comes from and why these are the same, so that we understand that long term. So one of the key things to notice here is I'm just going to multiply this across without actually doing the multiplication yet. So I'm just going to write it all in one big fraction. I'm going to write it in a special way, so you'll see why in just a second. So this 8 times 3, it's going to be 24, but right now I'll just write it as 8 times 3. And here this is 15 times 2. So I'm going to write this as 2 times 15. And what I want you to see here is that this is just making use of this. Here, 8 divided by 2 went across horizontally, but here, 8 divided by 2 is going vertically. They still mean the exact same thing, though. 15 divided by 3 was horizontal here, but now 15 divided by 3 is vertical. And it may look a little weird because 15's in the denominator in the bottom, but this is okay. As long as they're on either side of a fraction bar, we can write 15 divided by 3 going up like this, 8 divided by 2 going up like this. The key thing is just that whichever number is in the numerator or denominator over here stays there for that first fraction. Those can't move. So when I do this, this is just the same as saying, okay, 8 divided by 2, that's 4. 15 divided by 3, that's 5. And notice here that my number is staying wherever the larger number was. So 15 divided by 3 is 5. The 5 is staying down here in the denominator with the 15. That's the really key point. Once I do that, my answer is 4/5, just like it was before. So when we're dividing fractions, if we turn to this problem down here, all we're doing when we multiply by the reciprocal is that we're thinking of this as dividing up and down instead of side to side. So here I've got 3/5, and I'm going to do 3 divided by 7 and 5 divided by 10. Here's my 3 divided by 7. Here's my 5 divided by 10. Now, once it's like this, it's really flexible in terms of reducing. I don't have to be stuck by saying, okay, I can only divide 3 by 7. I can look at any of these 4 numbers, and if one of them can be divided by another one of them, great, we're good to go. So here, 10 can be divided by 5, and that's it. 3 can't be divided by 7, 7 can't be evenly divided by 3, 7 can't be evenly divided by 2, so on and so forth. So then I can just multiply across. 3 times 2 is 6. And I've got that 7 in the denominator. What we see here is also giving us a faster strategy for reducing fractions. So let's take a look at this one down here. A negative divided by a positive is a negative. So this is going to be negative 4/9. 4 divided by 5. 9 divided by 6. Now, typically when I would go about reducing this fraction is I would multiply everything across. So this is going to be negative 4 times 6 is 24. 9 times 5 is 45. This is going to be kind of a pain to write out all the factor pairs and reduce, although I certainly can do so. But what I can also see is all that I'm looking for is I'm looking for a number that I can divide both this number by and this number by. And one of the things that I see right here is that I see that both 6 and 9 can be divided by 3. So what I'm going to do is I'm going to divide this by 3, and I'm going to divide this by 3 right here. So if I do 6 divided by 3 and 9 divided by 3, that's going to give me 2 and 3. So I can just go right through and I can see 4 times 2 is going to be 8. 3 times 5 is going to be 15. I could have done the same thing here, just divide by 3 there. But if I want to do it earlier, it'll make the process go faster.